Hello friends, welcome to my channel. In this video, we are going to discuss about the design of binary multiplier. So to design this binary multiplier, here we are going to consider the bits A1 and A0 and B1 and B0 bits we are going to consider. So this is the final circuit diagram. And finally, these are our product terms P0, P1 and P2 and P3. And if you observe this design, some of the bits we are considered here, that is A0 and B0, which is given to AND gate, and A1 and B0 bits and A0 and B1 bits and A1 B1, and these are given to, these outputs are given to half adder, and here also another half adder it is required. So how we select this particular combination? So to understand this, first of all, we need to understand the basic multiplication technique. For example, with the help of example, so now we are going to multiply these two bits. For example, 33 multiplied with 33, so 3 into 3, which is 9, right? So this 3 which is multiplied with this one. Next, 3 into 3, this 3 which is multiplied with this bit, so 3 into 3, once again 9. Next, this 3 which is multiplied with this bit, 3 into 3 which is 9, and this 3 also which is multiplied with this bit, right? Another 3 into 3, 9. Now 9 plus 9, so here the sum is 8, but the carry which is 1, right? So this is let us assume this is the carry C1. Let us assume this is the C1 is the carry, this one is the carry C1. So 9 plus 1, so this is the sum, and here the carry which is generated, that one, right? So that one which is the carry, let me mention here, this is the carry, let me take, this is C2, right? So that this is the final answer, 1081. So this is the P0, this is the P1, and this is the P2, and this is the P3, and these two are the sum products, right? So now let us come to these bits. So then you can understand how we selected the half adder, then you can understand easily. So for example, this is the first half adder, so which is required to add these two bits, and this is the second half adder which is required to add these two bits, and here the carry is generated while adding the first half adder, that carry which is given to the uh, next successive bit. That is the reason the first half adder, the sum is the one output, that carry which is given to the second half adder input. So here also, while adding this 9 and 1, while adding these two bits, right? So with the help of this carry and these bits, while adding these bits, if this is the sum, if any carry which is generated, that carry which is shifted to the next one, right? So this is the C2 carry. Actually, this is the C2 carry and this is the C1 carry. The same thing I mentioned here, right? And finally, that is our output. That is P3, P2, P1 and P0. So this is the output. So to understand the same thing, how we consider this this AND gate and half adder, these two half adders, the simple the technique you can observe here. This is the A1 and A0 which is multiplied by B1 and B0. Only these bits only we are considered here in the design of the circuit. So first of all, A0 which is multiplied with this B0. Next, A1 which is multiplied with this B0. Next, A0 which is multiplied with this B1. Next, A1 which is multiplied with this B1, right? Now finally this A0 B0, now we are going to add these two. So this is the same value we are going to consider here, A0 B0. Next we are going to add these two bits. While adding these two bits, sum is generated, right? So let us assume that is S1. If any carry which is generated, that is I mentioned here, that is C1. C1 is the carry. Now while adding these two bits, another half adder it is required. So this is the half adder, and this is another half adder it is required. So C1, A1, and this is B1 actually. So while adding these two bits, another sum which is generated, and if carry may also generated, or maybe or may not be. So let us assume if carry is generated, that is C2. So finally this C2 will be generated here. So This is the way. Now observe here, first of all, A naught, B naught. So A naught, B naught, 4 bits I am considered here, A1, if you observe here the inputs A1 and let me take here A1, A naught and B1 and B naught. So here A naught, B naught, so this is the output. So the directly I am taken here, that is the P naught output, A naught, B naught. Next, I need to add A1, B naught and A naught, B1. So that is the reason A1, B naught bits and A naught B1 bits I am added here with the help of 1/2 adder. So that is the sum output which is taken here, that is the S1 output, and let us assume this is the P1. And if carry is generated, that is shifted to the next successive bits. That is the reason this carry which is added to here, next half adder. This is the second half adder. So the same thing I mentioned here, right? So while adding next A1 B1, see here A1 B1, which is the carry which is it is the carry is also we need to consider, that is the C1 carry which is we need to consider. To add these two bits, another half adder which is required, this is the second half adder. So that is the reason here this is the second half adder, and the outputs are nothing but sum and carry. The sum I mentioned here, the carry which is that C2 I mentioned here, right? So that C2 which is nothing but our final product, that is the respective final products you can observe here, final outputs, that is P3, P2, P1 and P0. So hope you understand. This is the binary multiplier design. I think with the help of these two examples, you can easily understand. So this is the way we need to design the binary multiplier. So hope you understand this video. So if you understand this video, please like, share and subscribe my channel. Thank you.